Hello. Yeah. Okay. So let's get started. And this is the okay. So this is the second lecture about inventory system. And yeah, we are actually standing here. So after this week, we are going to have just 1 week left, and we're going to have some review in next week. But actually, in this week, we only have some reviews about inventory models. So we're going to do some exercise. Excuse me. So we're going to see how this type of questions will be asked in the final exams and in the format of the final exam questions, and see how we're gonna solve them. Okay, so this is all about EOQ or EOQ extended models in this week. So first of all, let's do some review. Sorry, give me a second. I want to make sure that this one is working. Yeah, I think so. Yeah, that should be working. Okay, so first of all, and this is a very brief review of all the formulas and figures and models. So we take a look on this. Basically, we discussed the three type of models of inventory system. EOQ, which is very, very simple and simplified problems. So this figure is corresponding to the EOQ model, and EOQ with non-instantaneous and EOQ with shortage. So for the EOQ model, that's the simplest one. So we assume we can make an order or make some productions, and immediately we can aggregate all the inventories within no time, actually. So this is instantaneous. So we don't assume we need some time to aggregate everything to this level. So that means, and we don't actually, when we aggregate the level of our inventory systems, actually, we don't need to consider any demand because this takes no time. So immediately from 0 to the queue. Okay, so that's the assumption. So in EOQ model, we don't actually consider any productions, right? Because we don't care. Because we can immediately aggregate everything, so we don't care about productions and when we aggregate this. So we assume we can immediately having everything on our hand as the inventories, and then satisfying our customer, satisfying the demand. So the demand for EOQ is actually could be considered as D and small d, capital D and small d. That's annual demand and daily demand. And that could be very easily to calculate if we know either of the demand, annual one or daily one, as long as we know the days, working days in a year. Sometimes, if we don't know, and if you make sure, so we really need the days of a year, so we can actually assume a day, but you have to write it down very clearly. So we assume every year we're gonna working for 360 days or 52 weeks, every week 5 or 6 days. So if you believe that this is the required variables, but you actually don't know that from their questions, and you have no clue on what is the days. So you could have some assumptions, and later on maybe you can prove. So actually you don't need this, but that's another story. So if you really need this and you don't find the information, you can have some assumptions on this. Okay, so, and we can actually divide it for the optimal and quantities. So on this model, so the basic thing is we make the carrying cost and ordering cost the same, because that's actually the crucial relationship in all of the three models. So every time when we hope to find out the optimal model, so optimal order quantities, so that's actually the way we're going to find out. So making the carrying cost equals to the ordering cost. So that's the way. So the reason of that is we find out that the carrying cost and ordering cost, they actually have quite different relationship with the Q, so the order quantities. So what is the relationship? So do you still remember? So the ordering cost is actually a pretty linear relationship. So the carrying cost is actually a pretty linear relationship, but ordering cost is not. So if we combine them together, so actually we could have a very strange and curve. So we could basically find out a minimal one, so by make them equal. So that's actually a theory how we're gonna find out the optimal one. But you don't have to prove that, so that's pretty complicated and math problems. And so you don't actually have to remember exactly so this 3 formulas. And because those 3 formulas, if you need, you'll be given in a final exam, but you should know those variables, CO, CC, D, what is small p, what is small d, so what is CH, CS. So that's the crucial things. You have to identify those variables from the story, because every question is going to be a story. So they're gonna telling you there's a business, so they're doing some productions or they're ordering from the suppliers. So you have to figure out what is their D, their CO, and CC. Okay, so this is for the EOQ. And for EOQ with the non-instantaneous delivery or receipt, so we actually consider the time we aggregate the inventory levels. So that means, okay, when we aggregate inventory levels, we have to satisfy the demand at the same time produce or order the products from our suppliers. So that means, so during this process, so for our inventory levels, we have input at the same time output. So output is actually how we're gonna satisfy our customers. So we deliver to the customer. At the same time, we aggregate because the speed of the production or the order delivery is higher, is faster than the speed we satisfying our demand from the market. So that's the reason we can aggregate some inventory levels. So, and to find out the total inventory level, apparently we need 2 things, small d and small p. So this is quite different. So in here, we have to consider the small p, that's the production, daily production. So an annual production is P. So if you know the annual production or daily productions, you can basically calculate either one if we assume or you know how many working days you are going to have in a year. So this is very simple relationships. So if you know the P, so most of the cases you're gonna have to consider this model. And small d and small p, the ratio determines how quickly you can aggregate the inventory levels to here. And after this, so once we aggregate inventory levels to this point, so we stop our production or stop ordering from the suppliers. And then we purely deliver and satisfying the demand from the market. So the inventory levels will be decreasing slowly until one day we have 0 inventories and we order or produce again. So in here. Okay, so that's the reason we have to reconsider the optimal order quantities because we have to consider the P. So every day, so we produce something and we deliver something. So there's a ratio. So 1 minus D divided by P, that's actually the ratio remained every day as our inventories. So considering that, so we actually could solve another formulas in here. So we have to consider the ratio of P and D, so to find out optimal quantity. Okay. And also this is the carrying cost. So apparently this is the remaining things. And this is for ordering cost, that's actually the same. So carrying cost is actually a linear relationship, but ordering cost is quite different. And for the shortage, so we have slightly more complicated and relations because we allow some shortages in here. What if we have some shortage? So, and we allow S, that's the quantity of shortage, and also T2, that's the time we have 0 inventories, but we still have the demand from the customer. So we promise the customer, okay, fine. So we are going to deliver you later on when we have our products on hand. So that's the reason. Once we have everything, reorder or productions on our hand, firstly, we have to satisfy So the shortages. So this is something we promise to deliver to our customer before we aggregate our inventories. So every time when we have new inventory, that's total quantity is Q, but we have to minus S. That's actually the shortage quantities. So every time the maximum level of inventories is Q minus S. So this is quite different from the first one. In the first one, S is actually 0. In this model, if we assume S is 0, so this is actually the same as the first one. So we don't actually consider, when we consider shortage, we don't actually consider the production process because that makes the problem more practical and more complicated. It's out of scope for so far. Okay, so again, for this is slightly difficult to derive for the quantity, optimal order quantities. So you don't have to remember this, but you should know this is also from the relationship of carrying cost equals to the ordering cost. And actually, so this is the quantity of that. If you need to calculate, so those formulas will be given. So we have 3 models. So which one shall we use? So there's a crucial thing is called the production. So in most of cases, if you don't see any shortage, this keyword in the questions, and you don't see any productions, so they don't mention any productions. So most of cases, this is the only model you can use. But once they mention we have the production per year or production, daily production, whatever quantities, so you have to consider this because we have to consider the rate of produce and the rate of satisfying our demand. So this is quite different things. For shortage, so that's apparently, if they say we allow shortage, so that's the case, you're gonna consider shortages. So production, for most of questions, that's the only thing, and that's the most important quantity we have to consider to decide which model we're going to use. Okay, so this is a very simple, very brief summaries for all the formulas and 3 models. So this is our basic models, but this is crucial things. So optimal order quantity. Once we have this, so we can easily calculating some others like carrying cost and ordering cost, and also we can calculate how many orders we have to make in a year if we know the order quantity, optimal order quantity, and the annual demand. If we know how many orders we can make, so we could calculate, so in how many days we can order. Yes. Any questions? Okay, so that's some other formulas, but pretty simple things. So we don't include them here. Okay, after that, we're gonna start to looking at some questions. So this is one of the question in last years. Okay, so we take a look. This is actually pretty simple questions. And it's a story about, yes?
Expect this level in our exam?
Sorry? You mean expect this level of complexity or difficulty of questions? Yes?
Okay.
Yeah.
So no shortages, like, what do you say? Shortages, yeah.
Shortages? I'm not saying shortage will not be tested, but if shortage will be tested, that's also in the same format of the question. They're going to tell you, we allow the shortages, and then they're going to tell you what is S and what is time T2, so how long we allow for shortages. So I'm not saying that's not tested, so this is just the format of the questions. So the question always be like a story, like something like this. We have a company, we produce something, and so how many, no, I don't want to do this. Why we have this? Okay, fine. And so how many days we're actually work in a year? So this is apparently the first variables we can see. And the company produced with a rate of 64. So apparently this is something about production. So they tell you produce. So this is a daily production rate, apparently. And so they say the company going to set up the production line. Okay, if they say they're going to set up production line, so that means they're going to produce something by themselves. They are not ordering from the suppliers. So you consider the production rate and the setup cost and also the holding cost. So they say the setup cost is 500. And so and they tell you, okay, they're gonna produce Q, and then if when not producing rice, they're gonna do something else. So that means this is basically following our model. We produce something, and we aggregate a certain level of inventories, and then we stop production, and then we just purely satisfy our demand. And once we have zero inventories, we start producing again. So this is basically simple process. And yes, we have 500, that's the setup cost. And then we have holding cost. And so this is a unit holding cost for one package. So this is a £5 a year. And also they told you 5,000. That's actually a demand. This is the annual demand. So we know several quantities, several variables, and basic things. So they have, this is pretty standard questions. The first one always be, what is optimal quantity order? So order quantity. So find out Q, and then if you find this, so very easily to find out all the following things. So let's get started with, this is basic things. We can easily know what is P, daily production, and this is annual demand in here. And how many days we're gonna working, so 52 times day is pretty typical and configurations. So then we can know we have the annual demand. Apparently we know the daily demand. That's pretty simple. And so I've been asked for some times in the previous years, so how many decimal digit shall we keep? Actually, my suggestion is that for all of those calculations at the intermediate, if you could, you may just keep 4 or even more decimal digits. So the reason is that you won't have any propagation errors later on. Because if you, for example, in here, if you only keep 1 decimal digit, 19.2, that's okay, definitely. But later on, when you calculate some other questions, you might have slightly different results with the standard answer, because you have the aggregated error. Because in here, you basically truncate and by only keep 1 decimal digit. And for some others, maybe you truncate again. So you truncate many times. So finally, you will have slightly quite tiny difference from the standard answers. That's also okay. But if you really hope to make your answer the perfect one, so in all the intermediate variables, you can keep slightly more decimal digit. For example, in here, you can keep maybe 4 or something like that, or 3 at least. So, because a D, that's apparently the intermediate variables you calculated. You're going to using D for the future calculations for some others, for Q and for optimal numbers and cycle times. So you will use that for the future calculation. So for the intermediate, keep slightly more decimal digit. And for the final answers, so that's all okay. You can only have 1 decimal digit or something. So we don't have like a standard answer, so you're gonna have to keep at least a 4 for the final answer. No, that's all okay. So it's pretty flexible, but for your own actually precision of the answer, so for the intermediate things, keep slightly more. Okay, so this is simple things, and we know we can calculate in a daily demand. And then we could actually, if this equation was given, you can immediately use it. If not, you can apparently derive from this, but for most of the cases in the final exam, so this year, so you'll be given this. Actually, in the previous year, if you try to look at the past year final exams, you won't see these equations. The reason is that in previous years, Wolfgang believed, so this should be remembered. But I think that's okay, because you should understand how to use that. That should be fine. But for the inventory system problems, so I think as I said before, so it's not possible to have every single formulas there on the final exam. So this is a crucial one, definitely. You will have this. But for the later one, for example, if you know how to calculating Q, and apparently, yeah, holding cost and setup cost, so this equations will be given. And this is apparently it's not difficult if the formulas are given. So for this, D is annual demand, and P and D are all the daily production and daily demand. So we have all the numbers in here, and be careful about your calculations. Sometimes, and from the previous exams, I can see some of the students forget to have the square root. So they calculate everything correctly and forget the final step is the square root. So they have a huge numbers in here. So that's actually not good. So you're just one final step to the correct or full score. But if you have the wrong full score, all the previous steps are correct. You will have some marks, but not full mark. And for annual inventory cost, apparently holding cost and setup cost. So the holding cost is setup cost. Setup cost is actually the same for all the models. So that's based on how many orders you're going to make. So how many times you have to set up. So holding cost, that's actually proportional to Q. And so this is the remained Q level. So this is a ratio of remained. So you substituting everything, you will have this. Okay. And once you calculate what is optimal quantity and what is holding cost and setup cost, and probably you can calculate like optimal number of production runs and optimal cycle time and production length. So how to find out that production run? So apparently, so this is the daily demand and this is the quantity. So for every order, so we can have the ratio that's roughly 4.18. So for this formula, that will not be given because you should understand the meanings. So what does it mean production runs? So what is a Q, what is D? If you know the meanings, apparently it's just a ratio of that. And also optimal cycle time. So for this formula as well, not be given. So because this is pretty straightforward. So if you know how many runs you are going to make, and if you also know so the working days, so this is 260, that's how many days you're going to work in a year. So you can apparently find out how many days you have to make an order or how many days you have to set up to run your production line again. So this is the cycle time. And yeah, finally, production run length, that's equals to this. So this is how many you have to order or produce and divided by the daily production rate. So that's how many days, okay, for one production run. Okay, so pretty simple, isn't it? Okay, so let's move to another question. So this is on your problem sheet. So number one, if you're looking at this carefully, you will find out this is purely just another story, but with very much similar or even the same numbers as the previous one. And so the story is actually very similar, just two different products. So in here, they're gonna produce some pie and freeze them. So that means you have some working days and the same as the last question. And also you have the daily production rate, again, 64. And so you have to set up your production lines and produce something, and then you stop. And when you stop, you just purely support, basically deliver to your customers. So that means you have a setup cost, and every time it's a 500, and holding cost, you have to frozen. You need a refrigerator for all the pies. So this is the storage cost and holding cost. And you have a constant annual demand. So apparently we can repeat very similar calculations and steps as the previous one. So this is, so you can actually see how easy it is. So as long as you can identify so what problem it is and how you're gonna applying for every quantities, every variables, and substituting to the certain formulas. But you're gonna have to understand how to find out optimal cycle time and optimal numbers of productions. So apparently this is going to be the same, and production runs and optimal cycle time. So it depends on how many days you're going to working and how many times you're going to run the production line again. Okay, so yes?
Annual inventory cost, are we going to be given the formula or not? Or just for optimal production?
You mean the inventory cost? Yes, those inventory cost, holding cost, and setup cost, so that will be given.
So we're going to be given
Yes.
holding cost.
Yes, basically you have the cost formulas and optimal quantity formulas. That's
Like
all.
the table you
Table?
showed. Yeah.
You mean the first one? Some, I would say. Yeah. But again, so how to find out production run, cycle time, and this production length. So this will not be given because this is pretty straightforward. Yes. Yeah, I said. So the story is different. Yeah, but this is just I would say, coincidence. I don't know. So this problem in your problem sheet, you can find this question in your whatever PDF of the problems and for this chapter. And the previous one, this is the final exam questions in last year. So I just realized they are the same. I don't know. Okay, so second one, I guess you saw this before because we actually solved very similar ones in the lab session in last week. So we take a look on this again. So there's whatever steel company. So what we're gonna do is we're gonna order in some codes to operate whatever converters. So we have 12 converter. Each converter requires 5 tons of code per day. So, and because after last lab session, so I received some email asking me, so what does it mean? So for the converter, so this is going to be a production or demand. So it sounds like if we are running some steel company, we have whatever converters, that sounds like it's a production line. We are producing something. But actually, that's just our feelings. So the question is that you are actually a purchasing manager. So you're standing not on the production line, you're standing on the purchasing department. So your customer is the production line. So you're gonna have to satisfy the demand from the production line. So what is demand from production line? So they're gonna have to produce. So they need something as the raw materials. So apparently coal is the raw materials. So you are not trying to produce something. You are trying to satisfy your customers. So this is actually the key point. If you make mistake on this, you think, oh, this is a converter, so we have to produce something. So you might make mistakes on this question. So be careful about the stories. So maybe the story looks like a production line, but actually maybe you are not running a production line to produce. So on this question, you are actually satisfying a production line's demand. So in here, they say determine polyfill ordering code to operate 12 converter, each requires exactly 5 tons of coal. So apparently this is the requirements of the production line. So you're gonna have to satisfy them. So this is actually internal requirements, internal you buy from the supplier and you satisfy the demand. So the model, actually the mathematical model is the same, but quite different stories. So sometimes we consider a production line fine. Okay, we're operating that, we produce, and we support and we deliver to the outsider and customers. But in here is insider customer, it's a production line. It is the requirements from the production line. Okay, so this is the story from this. And so 12 converter, 5 ton per day. So this is actually the requirements and the demand per day, actually. So this is the first thing we know. And the firm operates quite a long time, 360 days and per year. So apparently it's the working time. And purchasing manager has determined that ordering cost. So apparently this is ordering cost. So when we say ordering cost, it's apparently from the suppliers. We order the code to support our requirements. So ordering cost is 80, and the holding cost is certain percentage of the value of the product we ordered. So what is the value? £12 per ton. So 20%, so this is 20% is not, we adding 20% more on the cost. So this is actually just a 20% of the cost of the value of the products. Okay, so that's pretty simple. So that's just 20% times the 12. That's actually the cost of holding the code. So that's the story. So that means we don't actually know anything about production. So yes, we mentioned about production line, the steel converter, but we don't know productions. So this is a purely very simple EOQ problems. We're gonna buy something, satisfying our customer. This is pretty simple. So that's just simple things. So we know ordering cost and holding cost. So this is the value of the products times the certain percentage. So in here is the 20%. So that's the holding cost. So, and this is how many days. And so if we know how many days, and so we can, this is actually the daily production we have. Yeah, that's my mistake. So it shouldn't be 6, it should be 5. So 12 times 6 is not 60, times 5 is my mistake. So how can I change? Oops, yeah, that's the case. Okay, so, and apparently we can calculate this. So this is the annual, so we know how many days we're gonna working, and so this is a daily demand. We know the annual demand. And so because this simple questions, we don't consider any production rate, so 2 times the annual demand, and COCH, that's the ordering cost and holding cost. We can find out the quantity. And once we find out the quantity, that's easy to find out the holding cost and setup cost. So actually, I guess maybe every time you find out when you calculate holding cost and setup cost, they are actually the same. So if you want to save your time in your final exam, you can actually calculate one and say they should be the same, so, and times 2, that's definitely your total inventory cost. As long as you can make sure, so the cost that you calculated is correct. Because in theory, there should be exactly the same. So maybe quite tiny difference if you're holding your decimal digit to 4 or 5 or 6. So you will see tiny difference.
If we hold decimals, do we make use of them, or we just say like they are the same, and then
So you don't have to prove they are the same. So
but
yeah.
for the answer, what do we write? Like with decimals or no decimals?
That's all okay. So you can, for the final answer, so I think the so rule of thumb is you keep 2 decimal digits for the final answer, and for the intermediate steps, and you may keep 4 for your own precision. Yeah. But sometimes you may have just an integer, so that's fine. Yeah. Okay, so next one, because we actually have done very similar things before. And as this one is at farm, we produce something. So the first sentence you will see, okay, we produce something. So that should be basically production things. So we know the annual demand, and so the farm produce, and yeah, that's actually annual productions. And so we know some carrying cost and also the transportation cost. Okay, so for this question, is apparently the first sentence they say production. So you have to consider like in this model. So we have to consider productions and demand at the same time. But so in the question, all you know is actually the annual demand and production. So, but in the actually small and formulas in here, So what you need is actually daily, P, and daily, D, so daily production, daily demand. So first thing, so one of the options, it's very simple options. You could assume we actually working 360 days. And so in the lab session, I said, actually you don't actually assume this, actually, because they are the same. So for example, in here, what if I write, where it is? Yeah. So what if I write something like this and times y? And in here, if I write times y, are they still the same? No? Or yes? Yeah, because we have y in here, we can immediately cancel them. So that's actually the same. So, but if you calculate p times y is how many days you're going to work in a year. So what is this? This is actually capital P. This is the annual production. And in here, so we have a small bracket times y. So you can times P and y minus D and y. So what are they? They are actually the annual production minus annual demand. So that's the reason actually how many days you're going to work in this question is really not very important. Because actually you can use the daily production, daily demand, or annual production or annual demand. So you could assume y in here, that's fine. If you actually understand the theories, you can say, yeah, we don't actually need the y. We can just immediately using P, the capital P, the annual production and annual demand in here, and substituting to here, we are going to have the same result. So in a previous lab session, we actually did the same things. So we assume a certain days, 360. We calculate a number, and then we copy that column, and we assume another days, another value for the working days. So we actually achieving the same quantities for the orders. So actually they are the same. So why we have the same results? So this is basically the reason. If we times y and y is in here, so we can cancel them. So actually that equals to, we don't times any y. Okay, so this is for slightly more difficult things for this type of questions. If you see, you will definitely need to consider productions, but you don't know how many days you're going to work in a year. So two ways. One way is you just simply assume how many days you're going to work in. Another way is you can try to prove, okay, we don't actually need this. So we can just using the annual production and annual demand to calculate the optimal quantities. Two ways. So one is a very simple just assumption, and the other one is you can have pretty simple proof in here. So it's up to you which one you want to use. Okay, so I guess maybe so far in Survey Learn, the slides you see doesn't contain this, but I will update the slides so later on you could take a look on this, why this is actually the same as using capital P and capital D. Okay, so if we calculate the Q's in here, that's optimal quantity, and for the others are pretty same. We can calculate the maximal inventory levels and also inventory cost and holding cost and setup cost. Okay, so and apparently the annual and inventory cost should be the same. And now if you're looking at holding cost and setup cost, they are almost the same, but tiny difference. 587, 588, so we consider them actually the same things. Okay, and if we know that, we can, okay, so the next question is, what if we increase the production capacity, and can we reduce the total inventory cost? Apparently, it is not possible to reduce them if we have this quite big production capacities. So actually, we've done this before in the last lab session. Okay, and next one, chocolate. So we always have quite different stories different products: chocolate, rice, coconut, whatever. So, but the theories or abstracted math is the same. So in this story, we have a chocolate company, that's fine, and with chocolate with coconut flavor, that's pretty cool because I like this. And operate 5 days per week and 52 weeks per year. So apparently these are working days. And production with a rate of 500 packets per day. That's pretty small actually, but that's fine. It's a daily production rate. And the company set up production line until determining the queue. And apparently they run production line for several days and then they stop. When they're not producing this, they're gonna producing some other products. So the setup cost for the production line is 1,000. Cost of holding one package of chocolate is 12 pounds per year. That's pretty expensive. Okay, so annual demand, we can assume annual demand is constant, 30,000 packages. So, and the questions are more or less the same. So we're gonna determine what is the quantity, what is total inventory cost, and optimal numbers of productions, and some others. Okay, so, and we know that this is the daily production rate. Apparently we are going to use, and so this with non-instantaneous receipt model. And 5 days a week and 52 weeks a year. So this is the total working days. And we know production rate. This is a daily production rate. Setup cost, holding cost, and annual demand. So we are working 260 days. So this is the daily demand. So apparently we can calculate, so what is the consumed ratio. So, but this is not compulsory, just to show some answers. So if we know the equations, so apparently we can substituting everything to here. So this is small p, small d. We know the small p and small d's in here. So we can immediately calculating the results. Yes, that should be correct one. If I make some mistakes on the final calculations, just let me know, maybe. And setup cost, holding cost, so that's based on different formulas. But if you're looking at the final results, they are more or less the same, but tiny difference if you're holding decimal digit for more than 2. And this is the total inventory cost, so adding the setup and holding together. Okay. And once we know that, apparently we can find out how many runs. That's based on the date, the annual demand, and the optimal quantity. And also, the cycle time is determined by how many days you're going to work in a year, and also how many runs, and also production length. That's pretty basic things. Okay, so this is also very similar calculation formats and just quite different stories. And the next one, also very similar. It's a final exam question and 2 years before, 2 years before, yeah. Okay, so it's also similar, but another story about cereal. Okay, and cereal with certain flavors. And we know how many days we're gonna work in, and we also know the production rate. Yes, the production rate. And also they run the production line and stop and run again. So they have setup cost and holding cost. So, and they assume the constant annual demand. So the questions are also very similar. So you're basically having the same calculation formats. So 5 days and so 52 weeks. So this and daily production rate. You got setup and holding cost and annual demand. So you basically could calculating if you have the formulas. So, but I guess if you practice all the questions, you could remember these formulas because if you practice many times. Okay, and if you know the quantity and you will know setup cost and holding cost, apparently they are more or less the same, but have tiny difference in here. And inventory cost, so we're gonna adding them together. And then it's how many and production runs, so determined by the annual demand and the quantity of one order. So And cycle time, so roughly 9.03 days. Okay, so you could actually answer the cycle time with unit of days or weeks, or if you like, you can convert it to month or whatever, as long as they are correct. So the units are not important, but for the cycle time, and it's important to write down your units. You couldn't just write, okay, 9.03 without a unit, so that's actually, you couldn't get the full mark. Maybe the number is correct, but you're gonna have to have a unit because this is about time. So 9, if 9 is a week or day, that's quite different. And production lines, so length, that's determined by the order quantity and your daily production rate. Okay, so 1.5 for days. Okay, so that's everything about inventory system. So I guess maybe in a presentation you will find out this is not easy to understand, but when you try to solve this, it's not difficult, isn't it? So for most of our questions, they have this type of formats in your final exams. You will be given some equate formulas. So optimal order, carrying cost, and ordering cost. That's it. So you'll have to know, if you know annual demand or annual production, daily demand or daily production, you have to know how to convert them. That's pretty straightforward. And you also have to know, if we calculate optimal order quantities, how to find out production runs, and also how many days you're going to have make an order or make the production, and also so the production run length, something like that. So those small formulas will not be given. So this is the crucial things. This will be available. Okay. So we're running very fast. So this is actually everything for today's lecture, and we won't have any lab sessions because we finished all the lab sessions previously. Oh, one thing is that there are, I don't know why, but there are a lot of mistakes of the configuration of Survey Learn about your online test. So sometimes they finish 10 labs, sometimes they show you finish 9 labs, but don't worry. So actually on the background, so there are records of every single questions you finished. So if you see some, if you're trying to see your scripts or your marks about the lab sessions, maybe they display something with a lot of errors, because they say you finish with, especially for week number 5, because I told the admin department, so we should have 2 questions, every question have 2 marks, but they make a lot of mistakes again. So I'm trying to figure out and make sure everything is correct, but so far it seems like it's not very correct. So don't worry about that. So as long as you make sure you answer every single questions, that will be fine, because all the marks will be given finally based on a spreadsheet of how many questions you answered. That will be fine. Okay, so don't worry about the displayed marks on the Survey Learn that takes mistake. No lab session. All lab sessions have been done for this module. Okay, thank you guys.